Bienvenidos, Hushamdeed, and welcome to this Hut 8 Consulting networking techtorial on Cisco's Enterprise Networking Security and Automation CCNA version 7 course. In this packet tracer tutorial, we're going to be taking a look at packet tracer activity 5.2.7, where we're going to configure and modify standard IPv4 ACLs. And so this activity is going to have us working with some numbered ACLs as well as some named ACLs, but they're all going to be standard ACLs, not extended. So let's dive in and take a look at the activity. So here is 5.2.7. You can see we've got a topology here, and we also have some internet connectivity out to an internet server here, 209.165.200. 254. We've got the addressing table over here on our right. And so let's go ahead and dive in. The first thing we're going to do, part one, is we're going to do some testing. So let's bring up PCA and let's see if we can ping with PCA to the hosts they want us to ping. And so can we ping PCD? So let me see if I can ping 192.168.40.3. And again, you can see PCD is over here. So not only do I have to go through router 1, but I've got to go through the edge router and then over what would probably be simulated here as they're trying to stress that this is probably some sort of a WAN type connection. So maybe this is Office 1, as you see, Office 2, and these are hundreds of miles apart possibly. So the ping is successful. Can we ping from C to D? And we should easily be able to do that. These are actually in the same office, connected to the same router. And let's see, can I ping 192.168.40.3? And as you can see, we've got no trouble, pinging PCC to PCD, but let's try from router 1, which is what they were asking there. I saw the PCs and we pinged a little early, so let's pull up this device here. Router 1, and can I ping 192.168.40.3? And we've got connectivity. It works great. From PCC, which we've already got opened up, can I ping PCA and PCB? Well, let's go ahead and ping 192.168.10.3, and that works like a champ, so we're good there. And if we can reach PCA, we should be able to reach PCB at 20.3. And we might have a packet that waits for the ARP request. There we go. And then we are through. So from router 3, and again, we're kind of testing all around the network here, making sure that connectivity is functioning before we apply any kind of ACLs. So ping PCA 192.168.10.3, and then let's try .20.3. And there we go. So from router 3, everything works. Can all the PCs ping the server at 209.165.200.254? So let's give it a try. So 209.165.200.254, and we should be able to hit the server after we probably have a one request timeout there. We do, and then everything is good. Let's pull up PCB, and we're also going to have almost all the devices we need open here for the work we're going to be doing. And let's see, can I ping over to 209.165.200.254? And that works without a problem. PCC, let's go ahead and say ping 209.165.200.254. And that works great. And then finally, PCD, which is the last device that we need to open up. Let's give it a try here, and let's go to our desktop, and we'll say ping 209.165.200.254, and everything works. So now we're going to configure, and let me give us some space here. We're going to configure and verify some standard numbered and named ACLs, right? So it talks about the standard ACL filtering traffic, and it can, remember, key takeaway here, we can only filter based on the source IP address in the packets. And that typical best practice is to get the ACL as close to the destination as possible, right? So we're going to create a standard numbered ACL that allows traffic from all hosts on the 192.168.10.0/24 network and everybody on the 20.0/24 network to access all hosts on the 192.168.30 network. So The security policy also states that an explicit, right? Remember, there's at the end of every ACL, there's an implicit deny any. What this is saying is we are going to be placing an explicit deny any. Access control entry, or ACE as we've been referring to them, and it should be present at the end of all ACLs. And the reason for that is, again, we can see if traffic is hitting that ACL, and then we could do some further forensic analysis to determine who is hitting that ACL. So it's asking about the wildcard mask. Well, we know the wildcard mask is the inverse. So let's go ahead and configure this on router 3. Right, so the first thing we're going to do is go from user exec with the enable command into privilege exec and then into global config. So if I say do show access lists, you can see that nothing is defined right now. So we're going to say, oops, sorry, too many C's there. We're going to say access list 1, and let's put a remark in here. Right now, what would you put in the remark? Maybe you can put in a quick note. Typically, what I put in my remarks is, ACL added on. And this is probably going to impact the score, so I'll pull this back once I tell you what I usually, ACL added on 6.29.2020 by TP bond fee, and then maybe even the CCR change control request number. That way there's some sort of artifact leading you back to who, what, and why, right? So we're going to say allow R1 lands, whoops, get it, access. So we're going to allow R1 lands access. And then I'm just going to recall this access list 1. We'll pull this back. And so it's pretty straightforward, right? Permit 192.168.10.0. And we know that the wildcard mask for a /24, which has a subnet mask of 255.255.255.0, the wildcard mask is the inverse. And then let's go ahead and say access list, and actually we can just, we can just pull that back and then float down here and add in the 20, right? Now, remember, we want to make sure that we get the access list 1 deny any at the end so that we can capture that activity. Well, let's go ahead and come out to privilege exec, and we'll say show access lists. I could even say show IP access lists, and we're going to see that. I could say show access lists, and what do we use? Number 1. And then again, if we had more than one ACL, that would limit it to us only seeing access list 1. We take a look at that. It certainly meets the requirements. Let's go ahead and jump into interface gig 000. Whoops, sorry, get into global config, gig 000. And then let's say IP access group 1 in the outbound direction. Now remember, we're talking about access here to PCC. And let's double check that. Where are we at here? I'm just looking at the, oh yeah, the hosts on the 192.168.30. And if you come back up here to the addressing table, you can see that this is PCC. I just wanted to confirm that before we moved on. And so let's go ahead and apply that ACL. And so they want us to go ahead and check to use the show commands to see what might be configured here. So I could say show access list, right? Again, we've seen that. There's my ACL. But what about that go-to command I talked about? Show IP interface gig 000 and then include access list. That is what we're looking for. You can see outgoing access list is 1, right? So we've applied that ACL in the outbound direction going toward the 192.168.30 subnet. So if we're only allowing PCA and PCB, what's going to happen when I try to ping the 192.168.30.3? Again, this message that we're getting here, reply from 192.168.41, destination host unreachable, right? This is very different than when you would see like a timeout, request timeout. This is indicating to you that there's an ACL that could be in place somewhere, and that is why the destination host is unreachable. And that's why we're getting that answer back that we're receiving. Again, they show you the show IP interface command, but again, I would I would go ahead and trim it down, say access list, and it's going to show you the outgoing and the inbound, outbound ACLs that are applied on that interface, that specific interface. And you don't have to look at all of this other information unless there's something in this other information that you're interested in. So we tested the ACL where we should have it denied. Let's test to make sure that the connectivity still works. So let's say ping 192.168.30.3 and PCA works. What about PCB? Let's say ping 192.168.30.3 and PCB works. So we validated not only is the ACL applied, it's applied in the right direction, it's applied as close to the destination. Oops, sorry, I keep moving it there a little bit. As close to the destination as possible, which is this gig 000 interface on router 3. If I placed it here and here, I'm blocking all, or I'm sorry, I would say I'm permitting all source traffic, right? But it wouldn't be, I apologize, it keeps kind of moving around. It wouldn't be limiting who can get through here, right? PCD would be able to come up and go through. And where if I were to place it up here, we'd run into the same problem, right? Because we're permitting the PCA and B subnets to get there. But if I don't place it right here, and the mouse might be a little tough to see, if I don't place the ACL right here as close to the destination as possible, that would mean that PCD would be able to get over there, right? And that's not what we want, right? That's not what we want. Now, what if we placed it, let's pull those back. What if I was to place it right there? Now, would that have the intended consequence that we're thinking about? So PCA would be able to get there, PCB would be able to get there, but on that interface, PCD would be blocked. But again, it doesn't make sense to place it here, right? Because that is not as close to the source, the destination as possible. This is the interface right there. Again, that placement in this topology would do what we wanted it to do based off what we've read so far, but that is not where you would place it. So again, just some things to think about as you're working through these different activities. So we've got the successful pings going here. Let's come back over here as well as the denies. Let's say show access list 1. And we see that we've got some matches here for the 10 network, some matches for the 20 network, and then we've got some deny any matches that are coming through, right? And again, depending on how many you've got and how quickly they're incrementing would dictate whether or not you're going to take a look in to see, hey, what is going on here? Why are we getting all of this traffic denied trying to get to PCC? Now, let's try from router 1. Right? And this is actually going to be interesting. So if I say ping 192.168.30.3, right? You can see we get this destination host unreachable. That's what the U means in the ping return. Now, this, I'm really glad that this has been included in this activity because step D right here, this causes so much confusion with learners. The reason that the ping is being denied is because of where the ping is coming from. Where is it sourced from? And by default, the ping will be sourced with the IP address of the interface out which that ping packet goes. Let me repeat that. With ping, the source IP in that ICMP ping packet that goes out here to get to PCC is not going to use this network as a source. It's not going to use that network as a source. It's going to use the IP address of the interface out which the router would route that traffic. And that is going to be the serial interface right here that I just circled that connects to the edge. That's the source IP. And let's go, and actually I'm curious to see, Curious to see if, let me scroll down just a bit here and see if they want us, if they have you add that in. No, they're going to have you do something else down here. Yeah, so real quickly, right, to prove that that's what's happening here, if we go onto router 1 and we go into privilege exec and we say show IP interface brief, and we look at the serial interface 010, the IP address is 10.1.1.1. Excuse me. If we come to router 3, is 10.1.1.1 allowed here with the ACL? And the answer is no, it's not. And so what we would have to do, if we wanted to allow pings sourced from router 1, there's a couple ways we can handle this. This has always been one of my complaints with Packet Tracer. I can't say ping 192.168.30.3 and then source. If I do a question mark, you can see there's no command here to source, right? So from what interface do I want this ping request to be sourced? And from here, I could say gig 000, right? And I'm, again, assuming here that, what have we got? Yeah, 000 or 001. I could use either of these two internal interfaces here to source that ping packet because those are in the network range that's being allowed. So that's one way to test. Excuse me. The other thing would be to do an extended ping. So you can't do it direct from the command line, which I don't like. I wish that they would add that in. But you can do, sorry about that, you can do an extended ping and say 192.168.30.3, repeat count 5, datagram size 100, whatever for the timeout. And you know what? I think I hit enter too soon, so sorry about that. So IP 192.168.30.3. Repeat count, got to be careful here. Extended commands, yes. Show me those extended commands. There is the option we're looking for. Source, address, or interface, right? So if I say, and I think they typically gigabit Ethernet 00, they make you spell it out, I believe. I don't think you can say GI 000. So I'll say gigabit Ethernet 000, and then I'll go ahead and just hit enter through the rest of the way, and then take a look. Packets sent with the source address. So by default, on router 1, when I try to ping PCC, the ping ICMP request will have a source IP of the outgoing interface on the router, not these interfaces down here out which the packets will not be going to try to get to PCC. I apologize, it keeps moving around like that. So that is, again, a very, very important point. This is one of the most misunderstood concepts with learners, that when you're pinging on the router or from the router, it's going to use the source IP of the outgoing interface in the ping packets, in those ICMP packets. It's not going to be smart enough to say, oh, well, you must want to use one of these two networks here because that's what the ACL over here on router 3 says, right? If you think about that statement, it's kind of crazy. Router 1 has no clue what router 3 is doing, right? So that is why the ping, it says, was the ping successful? The answer is no, and it's not successful because the packet is being sourced, the ICMP ping packets are being sourced from the outgoing interface that has an IP address of, what was it, 10, show IP interface brief, sorry, 10.1.1.1, right? Now, if this is something that you want to have working on router 3, what you would have to do is go into global config. And so right now, they've shown us previously how I could say access list 1 and then say permit 10.1.1.1, right? Now, what just happened there? Take a look at the ACL here, and then I just add that on, right? That's how they showed us how to do it prior, right? But what is the end result of this? Do show access list. Are those packets going to be allowed? Permit host 10.1.1.1. No, because the sequence number 30 comes before 40. And what does 30 say to do? 30 says deny all traffic. In fact, I'll come to router 1 and we'll say ping 192.168.30.3. and the network is still unreachable, even though the ACL has a permit for traffic sourced from the 10.1.1.1 subnet IP address. We don't need a subnet mask because this is when you leave the subnet mask off. I'm sorry, when you leave off the wildcard mask, it is going to default to be exactly this address, right? So we've put in a /32. I can leave the quad zeros off because I'm using host. You can see how it put the host in there, even though the command I issued did not have it in there. So these are just other little kind of, shortcuts that you can use while you're working. So again, no wildcard mask required if it's an individual IP address. And more importantly, we are not getting connectivity through to router or to PCC through router 3 because the deny any is before the permit host 10.1.1.1. So how would I do this? And this is typically where users will become confused with numbered ACLs, but here's what would have to take place. Because I can't put a sequence number, I can't say like 25 and then say access list, right? I can't do that. You can't put the sequence number in from global config. You've got to get into IP access list standard 1. And this is how I can come in, and you can see it's got the NACL for named or numbered, and now I can put a sequence number in. In fact, I can say no 40. Do show access lists. So I remove sequence number 40 because it's not going to work there. And what I could say is 25 permit, and I could put host. I don't have to though, right? And because I'm going to put the host in, it's going to know, the router's going to know that that's going to be a host. Do show access list because it is a /32 IP. And now you can see I've got this entry in here at 25. So now let's come to router 1. Now let's ping over to PCC and let's see that right there it works exactly. Sorry. I'm getting a sore throat here. Exactly as it's supposed to. So let's do this. Let's get back into global config. If I want to modify a numbered ACL, right? And I want, maybe I'm trying to squeeze an access control entry, an ACE in between two others, or before that deny any, I would come in and say IP access list 1, access list standard 1. And now I'm in here, do show IP access list. And again, you could say do show access list. And do show access list. Hold on one second. I apologize. I'm on router 1. Wanted to be over here on router 3. So apologize for that. So what I can do from here is just basically clean this up, say no 25, right? Because that's not going to get us any points. In fact, that may cause problems. Do show IP access list. And now I'm on the right router. And you can see that we've got the ACL as they're asking us to configure that ACL. And again, remember in the previous video I said, when you're setting the deny any, why not put it at like 900? That way you've got room to work with. So you can go 10, 20, 30, 40, 50, 60, or 5, 10, 15, 20. And it's going to take a while before you're going to have to juggle moving this deny any rule that you've got here at the end with a sequence number of 30. Again, use case is going to dictate what that is going to look like and what your end solution will look like. But I wanted to make sure that I covered in detail those semantics behind modifying a numbered ACL, how we go about doing that, how I can shuffle the access control entries around. In fact, if I was to say 900, deny any, and then I could say no 30, let's say do show access list. And it looked like it pulled it out. Maybe it doesn't like that 900. What about 800? Deny any. Do show access list. And maybe it's not going to. There we go. So it didn't like the order that I did it in on the previous sequence there. But now I've got some room to work with. So let's just go ahead and say no 800. And we'll say 30, deny any. Right? So do show access list. And again, this is kind of showing you how you can go in and kind of juggle things with the ACL. All right. All right, so for step 2, we're going to configure a named standard ACL. And they give us the requirements that we have here. So let's go ahead and do that. And again, you can see with the named or the standard named ACL, we get a little bit more information. It's a little bit more descriptive. And we're going to do this on R1. So let's come on to router 1 here. Let's go from user exec to privilege exec and then into global config. And we're going to say IP access list. Remember, we need that IP at the beginning and start of that command for before access list when we're doing a named access list. And that's whether it's irrespective of whether it's a standard or extended access list. If it is going to be a named ACL, we need that IP keyword there at the start of this command. And so we're going to be calling this in all caps branch-office-policy. Now, what we're going to be doing is permitting PCC and permitting the PCD subnet, the 192.168.30.3 and then the 192.168.40.0 respectively. And we're going to be allowing them to get access to, where are we at? To the 192.168.10 network. And so you can see we've got the ACL ACEs, the access control entries that we need. So let's go ahead and say permit. Now, do I need to say permit host or can I just say 192.168.30.3, right? Do show access list. And just remember, when you're taking the certification exam, keep in mind that they, if you've got a question that says permit host, that is probably what they're going to be looking for. My guess is they're not going to leave it off and assume that you know that you could leave it off and that iOS is going to put it in there for you by default. Then let's say permit 192.168.40.0 with our wildcard mask, right? The inverse of the subnet mask. And now here's a question. It looks like they're leaving off the deny any at the end. And maybe there's a reason for this. We'll find out as we work our way through. Let's go ahead and say end. And I could say show access lists. And you can see on router 1, there's our ACL. Let's get back into global config. We'll go to int gig 000. And here's where we're going to say IP access group. And it's going to be, if I do a question mark, you'll notice it doesn't give us any help. It doesn't provide us with, the branch. We've actually got to spell the entire thing out. And this is where typos can happen. Believe me, I know from personal experience, this is where typos can happen. So we'll say IP access group branch office policy outbound. So where did this ACL get placed on router 1? We placed it on the gig 000 interface, which I believe is that interface right there. And it should be, right? Because for PCA, which is this network we're concerned about, right? That only allow host PCC access to that network. And then the 192.168.40, which is going to be PCD. All right, so we can see that we've got that information in there. Let's clear our screen here. And how would we see this, right? Well, I could say do show IP interface gig 000 and then include access list, right? And that's going to show me that that ACL has been applied in the outbound direction. It's a standard named ACL placed as close to the destination as possible. Right? And so we ran those configuration commands. And here they want us to test the ACL to ensure that only PCC is allowed to get to that network. Right? Now, again, we've put in for testing PCD, we've got this ACE, the access control entry for the 192.168.40. And we should be able to ping over to PCA, but we're going to test this out. We're going to see what happens. So what it wants me to do is let's come over here to PCC and let's see, can I ping 192.168.10.3? And I can. So it looks like the traffic's being permitted. Let's come to router 3. Now, remember, if I go from user exec to privilege exec, and again, I didn't need to do this, but I'm going to do it anyway, to go from user exec to privilege exec, just in case we need to get into global config. I'm going to say ping 192.168.10 .3. And you can see that we get the network unreachable. But remember, it's because on the router, when I issue the ping command, which IP address, show IP interface brief, is going to be in the source IP field in the ICMP packet that goes over to PCA or tries to get over to PCA. And if you guessed that it's going to be 10.2.2.1, you're absolutely right, okay? Because that is the outgoing interface that this traffic is going to travel out of in order to try to get over here to PCA. So that's why it fails. And that's why we're going to come in here and do the extended ping. So we're going to say IP, we're going to go to the 192.168.10.3, going to go into the extended without jumping by at this time, source address or interface. So what can we put in? We could put an IP in. I already did the interface, so let me show you the IP. We'll say 30.1. That's the, I believe, the gig 000 interface. Let's double check that. It is. And then let's just hit enter a whole bunch of times. And you can see that we are actually being denied access when we're trying to ping from router 3 over to PCA. Were the pings successful? The answer is no. Let's check PCD, right? And let's get in here and say ping 192.168.10.3. And you can see that the pings do succeed. Let me take one more look over here. Did I type in 10.3? I did. So we've tested the ACL, and it says to ensure that only the PCC host is allowed access to the 192.168.10. Well, it didn't work for PCC. Let's come over here. Let's check that ACL again. And let's make sure, did I permit 192.168.30.3? I did. And I permitted the entire 192.168. So when I pinged, it didn't work from the router because I'm pinging from 30.1, right? What does the ACL say here on router 1? So the ping is not going to work, and it shouldn't work from the router when I source it from 30.1, but it does work from PCC. Right? Because we've locked the ACL down. That access control entry with sequence number 10 is only allowing the exact match for the 192.168.30.3. It's not going to allow a match for 30.1. All right, so we've done our tests. PCC works, router 3 does not. PCD works over to PCA, and so we're good there. Now, we're going to do a quick modification here. And you can see a deny any should be at the end. An explicit deny any should be at the end. And they kind of walk us through how we would do that. So let's get on to router 1. And the reason that we want that explicit deny any is that we're going to see if traffic is being denied. We want to know that. Are people or are bad actors trying to get to PCA that are not supposed to be accessing PCA? So how do we do that? Well, we're already in global config, and we're going to call back up the IP access list standard. I'm going to say branch office policy. And if I say do show IP access list, do show IP access list, you can see that that's the branch office policy. Again, the implicit deny is doing what we think it should do, right? It's denying any other traffic other than those two ACEs that we have there, other than traffic that matches these two ACEs. But I don't see if we've got matches. Are there bad actors trying to do this? And so let's jump in here, and you can see we've got they want to permit, right? They're going to add in permission to come from this network here, that 209.165.224. So let's go ahead and put in the sequence number and say permit 209.165.200.224. And now this is a wildcard mask that always causes a little confusion, right? But it would be easy to figure the subnet mask out. The inverse of this would be 255.255.255.224, right? And that's why we end up with the /24. It's super easy. With a /27, right, which is going to be 128 plus 64 is 192, plus 32 is going to be 224, so we'd have a /27 on our hands. This would be the subnet mask, the wildcard mask value, 0.0.0.331. All right, and then finally we're going to say deny any. And that was it. You can see the completion percentage takes us out to 100%. And let's go ahead and say in. Let me save my config with a write mem. And then let's say show access list and see what we've got here. And there is our new ACL. So now, when we come over here to router 3 and I say ping 192.168.10.3, you can see we get the destination host unreachable. But more importantly, we actually see that that is what's happening, that we've got some denies that are hitting here, right? So we've taken a look at that. It says test the ACL to see if it allows traffic from that network segment and see if it allows it to return from PCA, ping the server. So we're going to try to ping the server here, 209.165.165.200, 254. And you can see that the traffic does work, right? Because the ACL that we have here on router 1 on that interface right here it's checking for traffic in the outbound direction. So when the echo reply comes back, that traffic, because of that ACL, right? The source IP of the ICMP echo reply will be inside of this 209.165.200, 224 network. Specifically, it's going to be that server, the 209.165. Let me get control of the screen here. The 209.165.200, 254. That is going to be the source IP in the ICMP echo reply. So when it gets to router 1 looks at its outbound ACL, and it looks at the access control entry or the ACEs for that ACL and says, am I permitting traffic with a source IP in that range, that 209.165.224 range, specifically this guy here? And the answer is yes. So we test the ACL to see if it allows the traffic. It does. And reflection questions. Standard ACLs are very powerful and work quite well. Why would you ever need to use an extended ACL? And that answer should be obvious in that we can only filter traffic using the source IP or network, and that causes some specific limitations. What if I wanted to filter traffic based off the destination network as well? Or what about an IP protocol? What if it's TCP or UDP or BGP, the border gateway protocol, right? What if I'm trying to do some filtering there? I can't do that effectively with great granularity like I can with an extended ACL. So those are just a few of the reasons why you would want to use extended ACLs instead of standard, although standard ACLs have a place in enterprise networks. So now more typing is typically required when using a named ACL as opposed to a numbered ACL. Why would you choose a named ACL over a numbered? And this, again, should be abundantly clear that it's much easier for me to look at the name of this ACL and say, oh, okay, this is the branch office policy ACL, as opposed to looking at it and seeing ACL number 4. What does that stand for? What does that apply to? What are we trying to achieve with that, right? So it leaves a lot open to interpretation when you have a number representing the ACL, because you're going to have to look at that ACL and try to figure out, what are we trying to do here? And if it's 1 or 2 access control entries, probably not a big deal like these here. But if there's 20 or 30 lines in that ACL, it's going to take some time to look at that and try to figure out, what are we trying to do here? What is this ACL for? So that is why you would use a named ACL over a numbered ACL. All right, well, our completion percentage, again, less important than getting down all of the granular details of standard named and numbered ACLs, is at 100%. So we're good with this activity. And that is going to wrap up this Packet Tracer tutorial on Packet Tracer 5.2.7, where we configured and modified standard named and numbered IPv4 ACLs. Best of luck to you in your studies. Thank you so much for watching, and I hope to see you in the next video.